Hi everyone, I am Guénolé Fiche, and today I will tell you about SwimXYZ, which is a large-scale synthetic dataset for swimming human pose estimation. So we introduced this dataset because the aim of my PhD is to develop motion capture in swimming. So motion capture is developing a lot in sports, being for preventing injuries or for optimizing the performance. So traditionally we use marker-based motion capture, but these methods are hard to use on a large scale because they are very expensive and they require calibration. But there are new alternatives to motion capture with vision-based motion capture. But unfortunately, these methods are very hard to use in the context of swimming for several reasons. So the first reason is that since these methods are vision-based, we need to extract visual features from the image. And most of the time, the feature extractor we use are not suited for aquatic data. And we also use motion and pose priors in order to generate realistic human poses. And we do not have many swimming motions. And so motion prior will be trained on very large scale database, but without swimming motions. And they are very different because there are a lot of self-occlusions and the horizontality of the body and things like that. So we introduced this data set in order to be able to train feature extractors. So it could be, for example, 2D key points estimation, and also to train pose and motion prior in swimming. So here are sample images from the dataset. It has more than 11,000 videos, so millions of frames, with 2D and 3D pose annotations. And we also provide some swimming motion in the SMPL format, so it's like 3D body and shape. So the videos would be more for feature extractors and the swimming motion more for motion priors or post priors. So how we created this dataset. So first, we need to create diverse swimming motions. So we started from a Unity asset when we just had one sequence per swimming stroke, so just 4 animations. And in order to generate more diverse motion, we used Guénolé, which is a neural network composed of GANs, which will be able to generate a range of diverse motions from a single motion sequence. And so you can see here on the image that first we will generate a very raw motions, and the deeper we go in the model, the more accurate will be the motion. And so with that, we have diverse swimming motions. So once we have these motions, we will, because for now we just have a skeleton, so then we will apply an appearance for the swimmer and make it do the motion. So we do it in Blender. And then we use Unity to create a virtual environment. So we can change a lot of things like the camera positions, the waves on the water effects, or the lighting. And then we just put the animation of the swimmer inside the environment and record the videos. So these are the parameters which are varying in the dataset. So we have the 4 main swimming strokes. We have a wide range of camera views. Subject appearance can vary in the skin color and for the amount of muscles. You can vary the quantity and the height of waves. The lighting, so the direction of the lighting is also changing because depending on the hour of the day, we want to be able to do pose estimation anyway, and also the speed of swimming and the starting position. So we demonstrate use cases of SwimXYZ. So first we can use it for swimming stroke clustering. So for doing that, the first thing we did is that we encoded all the motions using the periodic autoencoder of deep phase. So basically it's an autoencoder which will use the periodicity in motion to encode them. And the nice thing with it is that in the latent space, it's particularly adapted for calculating distances between motions. And so we visualize the motion with TSNE, and you can see that there is a clear demarcation between different swimming strokes, but also a bit of variety among them, because if all the motions were exactly the same, we would just have one little line for each swimming stroke. And so we can think that if we pre-train or train a swimming stroke classifier with SwimXYZ, we would be able to do swimming stroke recognition. And we also use it for human pose estimation. So first on the right, you have a table with results using VIT pose. So we fine-tuned the model on one of the swimming stroke. I think it was freestyle. And then we tested on our dataset as well, but on other swimming stroke, it was butterfly, if my memory is right. And so you can see that there is a clear improvement when training on our dataset. And on the left, you can see some samples of qualitative example on real images. So to conclude, we introduced SwimXYZ, which is a large-scale synthetic dataset of swimming motions and videos. And there can be a lot of usage, such as training 2D or 3D motion capture models, training swimming motion priors, or swimming stroke classifiers, for instance. But we could still improve the dataset. First, we could have better diversity among the subjects and the surrounding of the water, because we just have one surrounding, so the reflections are just of one building which is behind the water. And we could also have more annotated modalities. Since it's a synthetic dataset, we can annotate as many modalities as we want. And for now, we just have the 4 swimming strokes, but we could also add some gesture like the dives, for example. And if you want to download the dataset or see videos, here is the website of the dataset. Okay. So thank you for your attention. If you have any question, I'm here to answer.